Okay, we're starting chapter 10. We're on lesson number 1. The essential question is, how are fractions and decimals related? And we're going to be doing some hands-on work today. So we have a decimal is a number that uses place decimal point to show parts of a whole. Kendra has $1, 3 dimes, and 5 pennies. Model this a place value chart. Okay, so she has $1, 3 dimes, and 5 pennies. Okay, so if we were to put these in my chart, I have 1, which would match this. I have dimes, which would match a tenth, so I have those. And I have my pennies, which are hundredths of a dollar. I know that $1 is equal to 100 cents. $1 is 1 whole, so write 1 in the ones place. So I'm going to write 1 in my ones place. 1 dime is one of 10 equal parts of a dollar. One of 10 equal parts is 1/10. So 1 dime is $1, and Kendra has 3 dimes. So I'm going to write a 3 in the tenths place. 1 penny, let me move this. 1 penny is one of 100 equal parts of a dollar. 1 of 100 equal parts. So 1 of 100 is 100th. So 1 penny is 100th of a dollar. Kendra has, let's see if it'll let me write. It will let me write a little bit. 5 pennies. So in our hundredths place, we're going to write 5 pennies. And that's how it works to use dimes and pennies and dollars to represent your number. The decimal that represents the amount of money Kendra has in dollars is $1.35. Now we're looking at another way we can represent decimals, and we can use. So this whole box shaded, just like I've shown here, would be 1 whole. If I only have 1 bar of the shaded, just like I've shown here, this 1, that would be 1/10. And if I only have 1 little square in the whole grid, that would represent 100th, so the hundredths place. So we can complete the value chart that represents the fraction of the that is shaded at the right. So there are squares shaded out of a total of squares. I know that if I count 1, 2, 3, 4, 5, 2, 3, 4, 5, 6, 7, 8. So this is a grid of 100. And I see that there are no whole ones. There's not a complete model that's shaded, so there's going to be 0 ones. I'm going to count 1, 2, 3, 4 complete bars that are shaded. So I'm going to put 4 in the tenths place. And I see 2 hundredths, as it's showing here. So 2 goes in the hundredths place. So in order to write this number, I would write 0.42. That's how that one is written. Okay, Paulo has 6 dimes. So let's get out 1, 2, 3, 4, 5, 6. And Mark has 6 pennies. So 1, 2, 3, 4, 5, 6. how many times greater is the value of 6 dimes than 6 pennies? Well, first of all, I've got them kind of in the wrong place, don't I? Pennies should go in the hundreds place and dimes should go in the tenths place, right? So, how many times greater are these than these? If these are worth 1/100th and these are worth 1/10th, you've got 6 hundredths and you've got 6 tenths. So how many pennies would I need to represent this? I would need 60 pennies to represent that. So that means 6 dimes. Oops, can you see? 6 dimes is 10 times greater in value than 6 pennies. Each time you move up a place value, you increase your value by 10. If I go from the tenths to the whole, that is also increasing by 10. Just like if I were going from 1 to the tens place, that would increase by 10. So it's always moving to the left, I'm increasing by 10. And that's how that works with the place value. Practice. And this is the part that you are supposed to be completing on your own, but I'm going to go through them. What I would like for you to try and do is to pause the video and see how it goes for you to try and do these on your own, and then come back if you're stuck or if you're needing more help, and then you can watch more of the video and make sure that you're really understanding it. So, complete the place value chart that represents each set of dollar bills and coins. So we have $0, we have 4 dimes, we have 1 penny. So that's how that would look in coins. And if I need to fill in my number chart, I'm going to have 0, 1s, 4 tenths, hopefully you can see all those, and 1/100th. So that will be written like that. Okay, so now for example 2, it says $2, 9 dimes, 1, 2, 3, 4, 5, 6, 7, 8, 9 dimes, and 1 penny. So that's how that would look. And if I were to write it in my place value chart, I would write 2 1s, 9 tenths, and 1/100th. So I would write 291. Now if I were to write the decimal represented by the model that it's showing on number 4, I can see that I've got 1, 2, 3 bars shown, and each bar is 1/10. And if we combine all those, we get 3 tenths, which would be written 0.3, which would go in my number chart, 0.3. That's how number 4 is done. I'm going to set up for number 5. Okay, so I've just made a picture that matches here. Count the number of solid rows. You'll see there are 6 solid rows, and if you count the squares, 3 squares by themselves. Since there is not that is completely shaded, that means there is no ones. The 6 bars stand which would be like having 6 dimes. And I have 3 hundredths, so that would be 3 in the hundredths place, which means number 5 would be 63 hundredths. Pause and see if you can figure it out on your own, or watch me do one and then pause the video and see if you can figure out the rest on your own without getting all of them from watching the video. So if we have 2/10, is that the same as having 2 dimes or 2 pennies? Hopefully you realize that the tenths is just one space to the right of the decimal. So 2/10 would go here, and everything else would be zeros. So I could write it 0.20, and that's totally fine. If it helps you, you can do it that way. That helps you remember that it's actually dimes and not pennies. You can also write it, because when you're to the right of the decimal, the right are the ones that don't matter included. So that's how I would write 2/10. Now if I'm going to write 25 hundredths, I'm going to have 25. I have still no dollars, no whole, one and or anything like that, so I still have the 0 there. And I just write 25 hundredths. And I got out to the hundredths place, so I don't need to sneak any more zeros in here. And none of these problems will have that anyway. Okay, now I'm looking at 49 hundredths, 10, 20, 30, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49 hundredths. So I have 4/10 and 9 hundredths. It will be written for number 8. Last one, I have 73 hundredths. So 5, 6, 70, 1, 2, 3. So I have still no whole dollars, 7/10 and 3 hundredths, 73 hundredths. And that's the answer for number 9. Okay, now instead of writing anything, I'm going to draw on my pictures. And it says shade 7/10, which would be like having 2, 4, 6, 7 dimes. How would I represent that on my model here? I would need, each row makes 1 dime or 1/10. So in order to show 7/10, how many bars would I need shaded? I would need 1 bar for each dime or 1 bar for each tenth, which hopefully you'll see. Now if I wanted to show 51 hundredths, like in problem number 11, 51 hundredths. And that's how I do it with coins, but that's not what it's asking me for. It's asking me to show it with my model. So I'm just erasing 2 because I had 7, and now I've got 1, 2, 3, 4, 5 bars, which matches my 5/10. And I'm going to shade 1 square to stand for this penny that I've got there. So 51 hundredths would look like this with coins, which it doesn't ask for. I'm just showing you so you can relate to it. And you would shade 5 bars and 1 square. And that's how number 11 is done. Now to answer number 12, you're just going to circle which of these is greater and did. So for instance, if I'm looking at 4 and 5, without giving you 11, I'm going to give you how I would do that for number 4 and 5. And because I can see that 5 has much more shaded than 4, I'm going to say that 4 is less and 5 is greater. So that's how we would do that. I would circle number 5 because that is the greater one there. So you can pause the video and try and work these out on your own. Number 13, a flower has 10 petals. During a storm, 5 of the petals fall off. Write a decimal to show what part of the petals is left. So they've the 5 petals, 1, 2, 3, 4, 5, to show the 5 petals that fell off. So the yellow colored bars here are the petals that remain. And since it only had 10 petals, I didn't have to need the bars. So if these are the petals that fell off, then these are the petals that are still there. I see 1, 2, 3, 4, 5. So I could write that as 5/10, but it's not asking me for the fraction, it's asking me for the decimal. So I have no whole flowers. I have 5 petals, and I can't have 1/100th of a petal unless a little bit was left. So it would be written, and that would be like having 5 dimes. That's how that one is done. Okay, now looking at number 14, a movie theater has 100 seats. I had to divide my picture into the full grid of 100. 78 of the seats are full. So I have 10, 20, 30, 40, 50, 60, 70, 7 full bars. And I have 1, 2, 3, 4, 5, 6, 7, 8. 8 squares. And unfortunately, my picture doesn't look very good. There shouldn't be this big of a gap for only 2 squares left over, but it's still 8 grids there, or 8 squares. What decimal shows the seats that are full? So just because I know that we like our money, I'm going to show with dimes as well. 4, 5, 6, 7, 2, 4, 6, 8. That's how that would look with dimes and pennies. And as you can see, I didn't need to use any dollars. I still have 0 whole. I have 7/10, and I have 8/100. If I wrote it as a fraction, it would be 78/100, but it's not asking me for fractions, it's asking me for the decimal. I would write 0/100 and, that decimal we can say and, 78/100. We got out to the hundredths place, so that means we've got to the right value and we've got the right answer. Okay, so in order to become my own problem, and I can look at the problems that are up here, or I can look at problems that were previous in the story. The only thing that I do need to have is my decimal. It disappeared. 0 ones, 5/10, and 8/100, which could be read 58/100. We don't have to do addition or subtraction. We can just write a problem like what we see up here with number 13 and 14. You can draw or think of something that might have 100 pieces, or you can think of a place that might have 100 seats and make up your own problem. Maybe instead of a movie theater, maybe you're at some other kind of event, a concert or something where they would have a lot of seats. And you're just going to ask what decimal would represent this number. You can even do it with your dimes and your pennies if you choose. How can you relate decimals to a place value chart? Well, the place value chart works like any other place value chart when we're doing. It helps me, when I'm working out my problem, it helps me line up my digits. So when I get to adding these numbers, say I'm adding, and by using my place value chart, I can make sure my place values are all lined up and make sure that I'm keeping my values separate. Otherwise, I might end up with something like, and forget that this is a value of 10th and I need to move it over there. So that's how the place value chart comes in handy. It helps me to line up and separate each of my different numbers that go in the different value positions. Please put that in your own words.